Hi, everyone. Welcome to Waste 360's Nothing Wasted podcast. On every episode, we invite the most interesting people in waste, recycling, and organics to sit down with us and chat candidly about their thoughts, their work, this unique industry, and so much more. So thanks for listening and enjoy this episode. Hi, everyone. We hope everyone is staying safe and healthy during these unprecedented times. This week's episode of Nothing Wasted, you'll hear a session from Waste Expo. It's Changes Coming, Insights into C&D Trends. It's pretty interesting and it was pretty popular, so I hope you enjoy it and stay safe and well.
My name is William Turley. I'm the Executive Director of the Construction and Demolition Recycling Association, and you are in a C&D session. If you are interested in the largest material stream in the United States, you are in the correct room. There are three speakers today. I am one. I'm just going to talk briefly about what some of the stuff that's going on our industry, and then I'm going to turn it over to a couple of material experts who are going to talk about specific ideas and sectors of our industry. Here's what I'm going to cover today about what's going on with the EPA as far as their support of the recycling industry, life cycle analyses, results of a roundtable discussion we had at our last annual meeting, a little bit about a project that we're going to be doing on biochar and C&D fines, and finally another project that we're doing on regulatory roadmap I think will be of interest to you. The EPA got really kind of shook up what happened in China when those markets went away. Then that, of course, riled our industry just as bad, not as much as C&D, because we are mostly a local industry because everything we have is so heavy, although it does affect us to some end. The MRFs and MSW folks were very upset because their markets were gone in China. EPA decided they would try to step in and try to figure out a way to help out. So they set up a stakeholder group, which CDRA was part of, but anything from NWRA to the plastics industry to a very wide net of people was included in trying to figure out what we could do to promote recycling. They came up with four different projects or four different sectors to work on as far as how to improve recycling in this country. The first was education and outreach. Most of this is going to focus on MSW right now, and I'll get into that in a minute. But with education and outreach, the thought was that they would be training people on what can and can't be recycled. I know some of you who might run a regular MRF know that the dirty diapers and everything else that ends up in the recycling bin. So they're going to try to train people through using EPA's influence in order to improve what comes into a recycling facility, get rid of the contamination. The second was to support the materials management infrastructure, and that goes to with the legislative effort that is also going on. I'll talk about in a second. How can we improve the sorting techniques and technology out there in order to get less contaminated materials and improve what we're making with the end products? They also wanted to figure out a way to strengthen the secondary materials markets for the end products. Those of us in the recycling industry kept telling them that we can figure out how to collect it. We can figure out how to process it. Just we need the end markets. That is the most important part of this thing. And I think they're recognizing that, and that will be a big part of this effort. And finally, measurement. We got to know what we're doing with this material. What baseline do we have? And I'll talk, that's my next slide here. I'll talk about what they're going to go with. But I want to talk about the legislative effort going on that was started out with basically the plastics industry and SWANA, but it now includes a wide, diverse number of organizations, like 40 of us now, who are working on a bill through Congress to get funding for sorting facilities in order to support better sorting and even provide grants or low-cost loans to facilities in order to improve their operations and improve their clean up their end products. So how are we going to measure this stuff? The new thing is the life cycle assessment, cradle to cradle, whatever you want to call it. It will become the new standard. Tons won't matter, except to compute LCAs. And if you don't understand what a life cycle analysis, assessment is, or analysis, it is looking at every stage of the material from virgin to end use, be it landfill, recycling, or reuse. Tons won't matter except to compute LCAs. Obviously, in the C&D industry, we like tons because we look good, because we have a lot of tons available. But this is different, mostly because this has been driven more by the MRF type people. Packaging is lighter, so they don't like the tons as much. But they're also very concerned because they are recycling the same amount of tons that they have for many years, but as far as the recycling rate, but they're also doing more units. Packaging has become so much lighter that they are recycling more units, but they're not getting the credit. So they think that this LCA will help them look a little better anyway. We also would like to develop LCAs, the CDRA does, for building materials. There's a lot of them out there already, but they don't take in disposal options at the end well enough. So that's something we're concerned about. We want to make sure it gets done right. During our recent annual meeting in Brooklyn, we held roundtable discussions during one of the lunches with basically the leaders of the C&D recycling industry of what are the issues that they face every day. These are the guys who actually run the plants who do this stuff. And I know some of you were there and participated in this. The results were not surprising. End markets were the big number one thing, how to improve them, especially for these materials, wood and C&D fines and asphalt shingles. I could do a presentation on all of those for half an hour, but fortunately our next two speakers are going to cover the next two, the first two items, so I'll leave that to them. And the other one is regulations. There is a big disconnect between the public perception of what they want us to do, i.e. we must take every stick of wood and make a new lamp out of it, or some ridiculous thing like that. And you know, there's anti-biomass feelings and all that. They do not understand that we have business realities, we have to make money at this thing. We're not doing it out of the goodness of our heart. So that's the two things that we will be working on at the association. And some of this we've been working on for years, as you will see from Dr. Townsend's presentation. But this is the kind of thing that we will be working on in the future. Another project that we're going to do, and Dr. Townsend is going to be doing this for us, is a regulatory roadmap to help government officials understand C&D better. We are the quiet part of the industry. Everyone focuses on their bloody blue bins at the end of their driveway because that's where the votes are. There's so much more people who are involved in that end of it, which is not a bad thing. I mean, in a way it can be good, but they're not familiar with C&D and how it's an opportunity to meet recycling goals, because we have a very good recycling rate, especially when you get into the aggregates. We want to develop a document to help them integrate C&D into their materials management goals. So our process is basically we're going to have a stakeholder group work with Dr. Townsend and his students on developing this document, and we will provide the input on what needs to be in here and share it with the government officials going forward. We will profile many of the materials that are involved in the C&D stream. And with that, I believe that next up, I got to do the introduction part of Dr. Townsend, whom I've known for too long, 20 years, maybe, at least. Dr. Townsend is probably the most esteemed researcher we have in the C&D industry. He is a Gator through and through, undergrad, master's, doctorate, assistant professor, I forget it, assistant associate. Now he's a fully tenured professor at the University of Florida. So he's a big Gator who really has done a lot of work in the waste industry, a lot of landfill work, but a lot of C&D as well. And he does a lot of our work, and he's going to talk about a project right now that he did for us. Dr. Townsend.
Bill, as always, thank you for that wonderful introduction. So I'm Tim Townsend, University of Florida. Back in the 90s, when I first started my professor position at the University of Florida, construction demolition debris was a big deal in Florida. Even today in Florida, you can still landfill a lot of C&D in unlined facilities in the state, which might be a little bit surprising given the dependency we have on groundwater and how close groundwater is to the surface everywhere in the state of Florida. But it was a big deal. So we spent a lot of time doing research, and then a lot of that research we ended up working with the CDRA on. What I'm going to talk about right now is something Bill wanted me to address for this meeting, which is this thing called C&D fines. And if you don't know what that is, I'm going to try to explain it. Some of the slides I'm going to perhaps jump over relatively quickly so we don't get hung up in the details, but I'm happy to share anything with you or spend more time with you talking about it. I guess the big thing is that I want to go over what this material stream called C&D fines are. Again, if you're not familiar with it, there's a large industry that exists in this country and around the world that takes construction, demolition type materials, takes it to a processing facility, and similar to a MRF, materials recovery facility that you would have for curbside collected municipal solid waste, you process construction, demolition debris materials, trying to separate concrete from wood, from other components in the waste stream. And so one of the products are fines, and I'll go over a little bit more detail on that. And then what I really want to do is talk about how important it is for the recycling industry to have an outlet for these C&D fines, talk about some of the regulatory, environmental, market challenges that are out there, and then talk about some of the work that the CDRA has funded to try to figure out how to better manage these materials. So the idea is that at the beginning of a C&D recycling operation, typically one of your first components or your first processes is going to be a screen. Old days, it used to be a lot of trommel screens. Now, typically, it would be some kind of big vibratory screen or shaker screen. But the idea is in the beginning, you're pulling out a bunch of fine materials, and I'll show you a little bit more, talk a little bit more about what those are. Depends on what state you are. In Florida, we call it RSM, recovered screen materials, and that's the term that most of the folks in Florida know about. But in a lot of cases, it's residuals. Some people call it alternative daily cover, although it doesn't have to be used for alternative daily cover. But what it really consists of, imagine a bunch of debris from some dump trucks and some roll-off boxes coming into a site. They're screened out. All the soil, all the dirt that's going to be in that waste stream is going to be shaken out in the beginning, but it's also going to have small bits of concrete and brick and maybe wood and plastic and drywall and other materials that are in there. So typically the components are some type of soil fraction with aggregate, wood, gypsum, other components. And it's dependent on what facility you're at and the type of equipment that they have. I've seen some facilities, and I'll show you some photos, where it's big chunks of material because the screen size is real large in the beginning. Other facilities use a much finer screen size and they get a much different kind of product. If you've never been to a C&D recycling facility, I'd encourage you to go visit one, and I'm sure Bill and the CDRA can help arrange one at a local facility. There's different configurations. This is more of the simple, older style where it's a single sort line. You take debris that comes in, you screen out the fines with either a vibratory screen, perhaps some other type of screen in the beginning. Maybe have a magnet to pull out the steel, and then have a pick line. And then on that sort line, you'll have various employees who are pulling out the different components that you're trying to recycle, perhaps some of the materials that you want to landfill, depending on how you set up your operation. But the fines are going to be one of the products that you produce. One of the themes that I'm going to try to convince you of is that the way that many facilities operate now is the fines are considered more of a waste product, a residual. To really market these things correctly, though, you need to begin to think of this as an actual material that you're going to try to market. More common facility, which I'll show you a few photos of in a moment, are these dual line mechanical facilities. You'll have an A line and a B line. Typically what happens is the debris comes in, you split it, maybe with a 12-inch cut, something like that. You take the large materials, put it down one line, take the smaller materials, put it down another line. But at some point, you're going to screen out those fines. And those fines end up being, again, a component or consisting of soil and brick and concrete and other small pieces. Just a few photographs, and there are a lot of nice new facilities around the country that I encourage you to go visit. But again, typically you have mixed debris, process some type of vibratory screen. That's ultimately going to produce that first large cut where you have maybe 12-inch plus, 12-inch minus, 8-inch plus, 8-inch minus. But then the idea is you send them down different processing lines. But that smaller set of the sort fraction is going to ultimately be screened again, and you're going to pull out what we're going to call fines. And I know it's a little confusing if I use fine as an adjective, but the idea is the fines are now a product that are produced at these construction, demolition, debris processing facilities. This is from a trommel screen at one facility. Here's another trommel screen indoors at a C&D recycling facility. But the idea is you produce the fines, but then as it goes down that picking line, you produce other materials along the way. I'm not going to show you a bunch of photographs of that, but you'll have sort lines that are pulling out wood and cardboard and concrete and maybe shingles and maybe gypsum. It all depends on what particular type of operation, what kind of market you have. And there's some very, very elaborate systems around the country right now, which I'd encourage you to go see. So here's the challenge. imagine now that at a facility you have a bunch of these fines. What do you do with it? Well, as it turns out, there are some issues with just going out and reusing that depending on the market. Now, what a lot of facilities would like to do is they have a dump truck comes in, brings in debris. They'd like to backhaul something that looks like soil and bring it back to the construction site and use it as clean fill material. These trucks are in the business of moving aggregates, moving debris around, so if they could pick that up. The problem is it's not just soil anymore. Once it goes through that recycling operation, it is now a recovered product from a recycling operation. And so it has to go through whatever regulatory protocols or requirements that are there. And as it turns out, there are some things that are in construction demolition debris fines that have to be addressed. So several years ago, as Bill described, we helped the CDRA with a study where we went around the country, had samples provided to us. The operators would collect these fines, send it to us. We did quite a bit of sorting and characterization, which I'm going to give you a highlight of now. The CDRA has several documents which are out there available to members that go into much more detail on this. But to give you some flavor of materials that we get in, I don't know how well you can tell from the photograph, but if you look and compare maybe sample E up to sample C, you can see in sample C there's all those larger pieces. It looks more like garbage in this case. I'm not saying it is garbage, but it's a case where they have a larger screen size. And so all of a sudden there are things that are falling through that wouldn't necessarily be part of an aggregate product that you were trying to sell. So the challenge is that these C&D recycling facility operators, if they really want to have a good marketable product, they need to start thinking about how do they make the best fines possible. Not, hey, what do I do with this residue that I create when I'm pulling out the wood and the concrete and the other materials that are important. And again, one thing you might notice is the colors differ a little bit. It's usually depending on the type of soil, the type of debris, the geography that you're coming from. And again, the particle size distribution is all over the place. And again, I have several slides that go into a little bit more data that I don't want to bore you with too much. But if I could just leave you with the understanding that it's dependent on the facility. And you as the operator have the ability to create the fines or the product that you want. So if you get an idea of what's in there, you can see these are different particle size fractions. I guess the thing that I wanted to show here is in that study that we did, about a quarter of the material is greater than 3/4 of an inch. So you have some larger pieces, but as you go down in size, you have very fine material, and then you have some intermediate fractions. What's more important, though, is I want to show you that of that kind of larger than 3/4 inch fraction, what are the different materials that are in there? Because again, what we're looking toward in the future is how do you process this material to recover valuable end products out of that. So if you can look, these are just some results overall from those two larger fractions, but the idea is there's a fair amount of concrete that's in there. Now, if you've been to a C&D recycling facility, a lot of them target recycled concrete aggregate or crushed concrete. There is a valuable market for that around the country right now. There is a fairly large amount of that exists in these fines, but it's mixed with the other things. You can see the wood, the gypsum, which we'll talk about, and some other components which are in there. So again, the idea of what we want to do with this is we want to try to take a look at those different materials and what can we pull out to make the best product that we can. So again, just to get us on the same page, for a typical modern facility, on your B line where you've got the finer materials, typically then you have a screen where you're going to screen out small, fine materials that is now a product that your facility is going to create. You might go visit some facilities and they might be taking some of their other materials and grinding it up and mixing it back in. That's really not the fines that we're talking about here. We're talking about a soil aggregate product that you're trying to create that has some other materials in there. So what are the big uses of these materials? Typically, landfill cover is the one that's probably one of the more common ones. You might find the landfill that will maybe pay you some money for it, more likely charge you a lower tipping fee or perhaps take it in as an alternative daily cover. Probably the more ideal thing that most facilities are going to try to target is a fill material. If you could backhaul fines after bringing in loads of other material to a construction project, that would make perfect sense. And then there are a few cases where it might be used as a soil or an agricultural amendment, which I'll talk a little bit more about. The idea behind landfill cover is that, again, you're using it as a replacement for virgin soils. So if you're at a landfill site where soils are at a premium, if you could use that fill material, that's potentially of value to you. When you start talking about fill material outside of the landfill, there have been cases where we would use it as shaping and grading material, like golf courses, for example, and embankments and new construction projects. As I'll tell you, it's not going to make super strong structural fill as is unless you process it further. There's just too much light material in there. But if you could use it for shaping and grading material, and then I'll highlight a little bit as we go through the idea of it being a potential source of a nutrient. And really the nutrient I'm talking about is gypsum. So again, the three big markets, the issues that you're going to have with landfill cover that we run into is, first of all, to make a good landfill cover, it can't be combustible. So you can't have a lot of wood fraction in there. So you do need to process it to an extent that you don't have a huge amount of light material, woody material in there. Typically, the facilities can do that. The bigger problem, though, is odor. Okay. Now, for those of you who know anything about gypsum drywall in landfills, when gypsum is disposed in landfills, it can often lead to hydrogen sulfide, that rotten egg smelling gas, which is not only a nuisance, but at high concentrations is dangerous. And so that's been a big, big issue. We'll talk more about that. When it comes to fill material needs, this is typically then, if you're going to use any kind of waste-derived product as a clean fill, you have to look at the local environmental regulations. And that's where you start to look at how much pollutant is in there. It's a waste-derived product. It's coming from older buildings in some cases, some of this. So there might be a little bit of lead, for example, or some other materials. That's typically the most limiting factor. And then typically, if you're talking about as a soil amendment issue, normally what you're going to do is you're going to also have to look at what quality of the chemicals that are in there, and then does it provide a benefit? I won't go into a huge amount of detail, but understand this, is that at the state level, not really at the federal level, every state will have a set of guidelines for how to characterize environmental risk. And the CDRA members, when they first contemplated us doing this study, ran into this problem all the time. And we won't go into huge detail, but there's different ways of characterizing whether it leaches a chemical off or whether it's a risk if you just put your hands on it or if it's going to be used somewhere that someone's going to dig into in the future. You can actually go to a few states, and this is an example of Ohio. Now, they call it RSM here, similar to Florida, but you can find specific chemical quality guidelines for what has to be met. In other states, it's much more generic. In other words, you can go, and there is no C&D fines regulation or guideline. It's more based on all types of clean materials. The result is, and again, we don't have time to dwell on it, but if you go from state to state, perhaps even looking at that top line for that AS is arsenic. These are the different ranges of arsenic soil limits that you can use for it to be considered clean, and it varies, an order of magnitude in some cases. So you can go from state to state and be able to use fines in one state and not in another state. So one thing you have to be aware of is what your particular local regulatory issues are or contaminant thresholds are. Working with CDRA, the elements or the chemicals of concern that have jumped up the most, and this may not be too surprising to those of you in the waste industry, but lead. Because again, especially in some parts of the country, you have lead-based paint in some of these older structures. Arsenic, which I'll be honest with you, is really just a naturally occurring element that also is found in concrete. There's these other chemicals called polycyclic aromatic hydrocarbons, which I'll just call PAH. We won't go into great detail on the chemistry or anything. And then the sulfate. That was something that we did for CDRA. CDRA has a method for measuring sulfate or gypsum in fines because that can cause those odor problems at these sites. So, stepping back then, I'll just tell you that there are some potential issues with regard to these fines. So what can you do as a C&D recycling facility operator to increase your chances for enhancing the market? Well, there's a couple things you could do. Somehow you could modify the product. We have to somehow make a better fines product and tailor it to the market which we're trying to reach. Somehow you can control the risk. In other words, don't use it for everything that you might want to use it for, but limit it to certain areas where the risk is controlled. And then in other cases, do it on a site-by-site risk basis. And I'll share a little bit with some of these strategies. I'm just touching the big picture here. Bill, on the CDRA website, there's a set of guidance documents that go through all this in greater detail. If you're a member, you can get all this information. But one of the things you can do is just be smarter in the type of material that you bring in. For example, drywall. If you're having issues with gypsum in your fines, try to pull the drywall out. If you got a load of drywall coming in, don't put that through your process line. Try to pull the bigger pieces of drywall out. That'll save you a lot of issues from there. If you have a lot of demolition debris coming in, or I'll say a bunch of debris from a burned building, that's probably going to contribute some of the chemicals to your fine. So begin to target a little bit better. There's a facility in California, the Zanker Road facility, one of the best ones in the country. They actually take their construction debris and their demolition debris and they separate them on different lines, and they're able to maximize the use of their products because they get products that are tailored for specific uses. They can actually use their construction line fines as an agricultural amendment because it's clean and it has a lot of gypsum in it. Again, the things to think about, well, what are the source of these materials? Well, clearly the gypsum is from drywall, but arsenic, it might be from treated wood or maybe some soil that has pesticides, but usually, honestly, it's just naturally occurring arsenic. Lead, of course, being from urban soils or from lead paint. And then these chemicals, these PAHs or benzoate-pyrene, if you have a lot of burned material, maybe if there was some ash, if there was some other asphalt residue in there, you might find some issues on that. One thing that we went into understanding is that if you have asphalt products in your fines, it might cause some contamination concerns. And so the idea is if you have a little bit of a shingle, I've heard recycling facility operators say this, if you have a little bit of a shingle in there or a little bit of wrap from a processing operation, your benzoate-pyrene or your PAH concentrations might go up. And while the work that we did for CDRA shows that it's true, I'm not going to try to explain all this in detail. I think the big lesson that we learned, and this was a bit of a surprise to me, is that yes, the asphalt products do contribute a little bit, but they're not the thing that's really going to limit you in most cases. You can get some of those asphalt products out, but it's really just natural urban soils. In our cities, we don't have clean soils anymore. Okay, if you have a very urbanized city that's had lots of industry in the past and vehicles running around for decades and decades, it's going to have lead, it's going to have PAHs, and so the thing you have to work with your regulators on is what do you compare your results to? Are you comparing it to clean soil away from the city, or are you comparing it to urban soil and how you're going to use it? One of the things that we've always thought is, well, maybe if we screen the materials a little bit more, we can create a better product. And in fact, that can be the case. These are concentrations of arsenic, and the blue bar, forget about the numbers, but the blue bar represents the finer materials, okay? So what you find is a lot of chemicals like lead and arsenic tend to build up in the real dusty part. So if you can somehow screen the fines off, I know it's a little hard to say this, but screens the fines out of the fines, screen the real small particles out of the fine product, you can, in some cases, actually reduce your concentrations to below target levels. We've demonstrated that for arsenic. You can see we've demonstrated that here for lead. And we've also seen that in those organic chemicals that I've talked about. So screening can play a role. And if you go out, and I'm sure in this trade show, you'll see vendors, or Dick from General Kinematics is here. These newer screens you can buy and purchase have the ability now to really get you much finer products than you can in the class, finer cut sizes. So perhaps more screening will open up doors for product markets options for you. Well, one thing, and this is based out of a C&D facility of all places I visited in India, but they were taking fines, a little bit different than we have here, but they were washing it. If you've ever been to an aggregate washing yard, they actually have wash tanks or float tanks where they process this material. And what they were doing is they were washing. And so what you find is that potentially, if you were to wash these fines, now granted, there's costs, I'm not arguing with that, but if you're able to further process this to pull the aggregate out, you might be able to get a good product. Another piece of work we did just this past year for the CDRA was we did a washing experiment. Big pictures, you see those 3 different color bars in there? Those are just kind of the percent of the mass of a bunch of different facilities. Look at the grayish bar in the middle. That's your aggregate fraction. So it's not half, but it's certainly a sizable fraction. So perhaps we can pull out a fraction of the fines as a clean aggregate that we can reuse. Is that going to be worth doing? Well, somebody's going to have to sit and do the operational capital cost expenditure on putting in a washing system versus what your additional market, maybe your offset of landfill tipping fees is going to be. So we've been doing some work looking at washing. And what you find is depending on the facility, you can get maybe 40%, 50% aggregate. You get a fair amount of what we're calling floatables. These are the chunks of wood and maybe some plastic and other things that are in there. But then for other facilities, you'll just have huge amounts of the finer material, the dustier material. So the trick is that for your facility, you're going to have to look at that material. And by the way, the floatables, typically, it's mostly wood, but it's got paper, and it's got sometimes the drywall pieces will float to the surface. But the idea is you can create a cleaner product. So again, here's some results from the work we did for CDRA just this past year. But what you find is that the aggregate product that you can produce by washing the fines and pulling that out, in some cases, not all cases, is much improved with respect to some of these chemical qualities. So for example, here was arsenic. It really turns out for these facilities anyway, that arsenic existed on that fine, dustier material, but on the aggregate products, it was much lower. Not quite as notable for lead, but certainly there was a difference. If you can wash that material, you can produce that out. And even for those organic chemicals, those benzoapyrenes, that PAH chemical, washing will do a trick. Again, I don't know that washing is ever going to find its way into the mainstream in terms of being a cost-effective process, but I will say, though, that if you're a C&D recycling facility and you want to maximize the use of your materials, you got to think about how to strategically produce the best product that you can. Just to give you an idea, for A and for B, two different facilities, see the kind of the goldish and the grayish bars on the bottom, that's your aggregate fraction. And so what you're doing is if you're washing away all that real fine material, you're creating an aggregate product that you can potentially use. I put this thing, I don't know if you've ever heard of coefficient of uniformity. I'm not trying to go too much detail. But the idea, though, is that one of the things you do is you go from a rather, what I'll call well-graded fines product to a product that is much more poorly graded or uniformly graded toward an aggregate. So the idea is by washing, you are really focusing on pulling out just a fraction of the reusable aggregate market from the fines. Your density goes up, which makes it much more likely to be used as a structural fill material. And then your specific gravity goes up, same kind of thing. And in fact, in some cases, for some of our testing, you were approaching the specific gravity that you'd get for RCA, or recycled concrete aggregate. Again, there's a lot more of this information that I can go over with you, but again, I would suggest you contact Bill and the CDRA to get a lot of that. So one thing you can think about doing is, well, what about just washing? Well, again, you really need to look at the economics. What about treating? You'll be approached by people who are going to sell you different materials that you can add to it to make your problems go away. The thing to remember is lead and arsenic don't go away. You can't spray something on it and make those go away. Potentially, though, you can get those PAHs to degrade. And I'll go through it quickly, but one thing that we did for the CDRA this past year is look at, can you, if you almost compost these fines, or if you age them, can you get some degradation? And what it looks like is yes, is that if you let them sit long enough and you process them correctly, you can get some degradation. And again, I don't want to throw too many details at you, but a student who's just finishing up this semester looked at if you took these different components of fines and you aged them in an aerobic environment, you can get some of these chemicals to degrade. So potentially, there's a way that you can go ahead and treat these materials, at least to reduce some risk. Another thing to do is to say, well, I want to use the material, but I just can't use it in everywhere. I have to go out and I have to use it in certain settings. And so you know what a brownfield is, if you've heard of a brownfield setting, but the idea is that maybe don't use it as just clean residential fill, but use it on specific projects, use it as highway embankments, use it under buildings, maybe in a golf course, things like that. You'd still have to consult with the regulatory agency. One thing that's being considered is, can I create products by blending different materials together? Can I take the fines from my concrete crushing operation and mix that with the fines from my C&D operation? Or Tom's going to come up and talk about next something that we're going to be working with CDRA on, about blending biochar, for example, which could be created from the wood from the C&D recycling operation with these fines to produce a product that will limit its problems either when it's land applied or when it's disposed of in a landfill. Again, you always need to consult your regulatory agency. And then one of the last strategies that are outlined in the CDRA guidance document is that remember, all the risk levels and the regulatory guidelines that you would have to consult before reusing any waste product in the environment, they're meant to be pretty conservative. And if you have a specific site where you want to reuse materials, there's always opportunities to do more site-specific risk evaluation. A lot of times that's difficult to do. One thing, for example, and I took out the data because it's just too much to go into now, but a lot of the risk calculations assume that all of the chemicals are available to the human body if they are somehow consumed, okay? Now, I know nobody's thinking we're going to consume C&D fines, but that's how these risk assessments work. And so we've also done some tests for the CDRA and have some data which shows that not all of it, even if you were to ingest or dermally contact some of these fines, would enter the human body. Only a fraction that is what we call bioaccessible or bioavailable. And so on a site-by-site risk assessment, we can use that data to help better narrow in on what the true risk is going to be. So with that, C&D fines are important if you're a C&D recycling facility operator. They might be 20% of the mass of your facility. And if you can't get rid of that and you're paying a huge tip fee to put them in a landfill, you can't always make your facility work. So finding markets are important for that. What the CDRA has done is they have identified a bunch of potential strategies for doing this, anywhere from just process more smartly the materials you get in, all the way to screening and washing to controlling the risk and blending. These are outlined in a couple of documents that, again, are available to CDRA members, and Bill can tell you how to get to all that. But then in the interest of time, what I'm going to do, here's my contact information. You can get with Bill, and on the website for CDRA, they have all this material. I'm happy to spend more time talking about it, but just understand that it is one of the problem materials. Another material that you need a good market development for is all the wood that's produced, and that's what Tom's going to come up and talk about next.
Thank you, Tim. That was very useful as always, especially for those of you who are operating plants. One of the big products categories that we have problems finding end markets for is our wood. As the price of natural gas goes down, we are finding, natural gas is replacing our biomass facilities. So we're looking for new markets. Many of our members have become excited about the opportunities in biochar. And we're fortunate today to have probably one of the leading experts in the country on the subject. Tom Miles has been in the wood products and biomass industry for more than 40 years. He's director and everything else he wants to be for the U.S. Biochar Initiative as well as the International Biochar Initiative. And he's going to talk about what this new product can and can't do. Tom?
Thank you, Bill, and thank you for the including me in the session to help kind of spread the word about what biochar is and what it isn't and how it might be used in this industry. What I'm going to try to do is talk about biochar products, what they are, what the systems are that produce biochar, and the processes that might be used for making biochar from urban residues, and hopefully convert some of your residues to value-added products. You might be interested to know that there actually are a few operations now, C&D operations, that are making biochar from the wood fraction, combining the biochar with other materials in their composting operation and making some value-added products. So it's happening now. I became interested in biochar, again, as Bill said, I've been involved in this business in biomass. I'm fourth generation of my family in the wood products industry, spent a lot of years with biomass, combustion, gasification, pyrolysis, conversion of biomass to different forms, and became interested about 10 years ago in biochar as it became kind of discovered that this charcoal in the Amazons was responsible for contributing to improvement in soils, and the fact that maybe we could use some of the byproducts of other processes to benefit nutrient management, manures and sort of thing, and the disposal of wood products. There are actually two organizations. I'm a volunteer director of both of them. The U.S. Biochar Initiative is North American based. We basically host conferences every couple of years. The next conference will be in Fort Collins, Colorado, at the end of June and in July. We send out announcements, newsletters, have a website, exchange information on social media, and do a lot of education outreach and workshops. The International Biochar Initiative was organized in 2008. It's international in scope. It's a membership organization. There are professional, business, and organizational membership categories. And we do monthly newsletters, special white papers. We have a science committee. do webinars. Upcoming webinar is on cascading carbon, different ways in which you can use biochar to go into building products, all kinds of other activity. We're pretty active in social media, and we also do education outreach and study tours. So what are biochars? Who buys biochars? How do you make biochars? And are biochars worthwhile in your business? And if you look at the slide on the left-hand side, you see that this is a scanning electron microscope image of wood biochar. You see that honeycomb kind of an arrangement. Biochar is simply charcoal that's been cooked longer than the charcoal you normally make for your home barbecue, so that the oils, the tars, and so on have been cooked out. You wind up with this honeycomb kind of microstructure, which is an excellent both mechanically and chemically for absorbing materials of various kinds, and mechanically actually for absorbing moisture. So biochar, when it's combined in the soil, combined with other ingredients, will hold on to moisture, and it will also hold on to nutrients. On the right side, you see mycorrhizal fungi hyphae that are growing in the spores, and what it's doing is that it's sending its hyphae into the pores of the biochar, where it's finding nutrients. It's feeding off of the nutrients in the charcoal. And so in that way, biochar becomes a habitat for microorganisms, and what we find is where we combine biochar with other soil ingredients, we wind up with an increase in microbial populations and also an increase in nutrients. It'll capture and hold potassium, sulfur, nitrogen, other nutrients, and then as the plant roots call for that particular component, it'll feed the root structure. So it winds up acting as kind of a slow release mechanism for nutrients. They're made in different forms and qualities and different uses. The left-hand side, that's a picture I took about 10 years ago when I led a group to the Amazons to look at the soils in the Amazons. Some of the charcoal soils along the banks of the Amazons are 40 to 50 feet deep. Literally thousands of years, up to 4,000 years of burning vegetation along the banks of the Amazons created this man-made soil or anthropogenic soil, which is a mixture of charcoal, sewage sludge, kitchen waste, all mixed together. And what it did was take a very poor, low-quality soil and turned it into something very productive. So growing up, we were taught that the soils in the Amazon were very rich. Actually, the soils in the Amazon are very poor. But along the banks of the Amazon, where people lived, in an area that covers the size of France, there are some very, very rich soils that basically are these man-made soils where charcoal was incorporated into the soil through various processes. And now with industrialization, we have, there's a chip-like char you can see on the right-hand side. Left-hand side, go through a screening process. You make smaller particle size. That's a 1/4-inch grid. We have some people that are pelletizing chars and granulating chars for use in agricultural seeders, and even combining chars with fiber for use in erosion control. And on the right-hand side, there's liquid charcoal, a new product from a company called Lesco that's been put out for using biochar. It's actually an enriched biochar with some biology, some other things in it, and it's sprayed on golf courses. So who buys this stuff? Who buys biochar? Biochars are finding value in many, many markets. Initially agriculture. You can see the blueberries up in the upper right-hand side. Typically what we find is that when biochars are incorporated in the soil, even to a small amount, they tend to promote the growth of roots, and that in turn makes healthy plants. Often biochar is combined with compost. In California, for example, a lot of biochar has been used 5% by weight, 10% by volume with compost, and what it does is increase the water holding capacity of the compost by 25 or 30%. So it has been heavily used in drought situations, spread in rows, for example, in orchards and vineyards and those kinds of crops. China is making biochar-based compound fertilizers, which contain 15 to 25% biochar. What they found is that the biochar plus minerals plus the nitrogen, phosphorus, and potassium, and they combined together in a fertilizer and spread in conventional ways improves, again, the root growth and makes plants more resilient to drought and other activities. There are biotic soil amendments where you add more microorganisms. Biochar is a great carrier for microorganisms, and it can be granulated in a product and added to fiber for hydroseeding. Environmental markets are also growing. We have situations where we've used biochar to capture heavy metals. In the Northwest, we're concerned about copper. Copper at 9 parts per billion in the estuary will kill salmon fry or baby salmon. So we're concerned about capturing copper from our stormwater. We find that adding biochar to our bioswales, to our filtration systems, takes that copper out, and the biochar will last in structures. We have structures now that have been in the ground now or in bioswales for 10 years. We think that they'll last about 20 years before they're saturated and need to be replaced. Biochar is being used in sewage treatment plants for odor control. Biochar is actually being made from sewage solids, interestingly enough. Makes a very good soil amendment especially for golf courses. Being used in mine reclamation, it's very good for stimulating microbial growth, for remediating mines, oil fields. I mentioned stormwater, but we're also seeing biochar finding its way into non-soil carbon products or non-soil uses such as animal feed. It's actually illegal to feed charcoal in the United States since 2010, but there's a movement to go back to that. It's very good with regard to very beneficial in animal feed. It's finding its way into building products, actually. Combined with gypsum, for example, it will reduce the electromagnetic transmission from the electrical lines in your house, so you're exposed to less radiation if there's charcoal in the mix. Used for odor control, as I mentioned, and also food products. So who's making biochar? We're a small industry. We know of about 135 producers in the United States, another 15 producers in Canada. As you can see, a number of the producers are on the West Coast. There are a number as well in the Southeast. On the West Coast, biochar tends to be produced as a co-product of the biomass energy from the biomass energy plants. But as was mentioned earlier, biomass plants have been shutting down, which has been a huge challenge. In the Southeast, much of the biochar comes as a co-product of the wood products industry in gasifiers that are used to dry southern pine lumber. And it's slowly evolving, going from what started out as a very small individual kind of basis to industrial plants. Here in China, for example, they produced 200,000 tons of biochar last year and made it into 200,000 tons of biochar-based fertilizer. Here's a plant that's going up. The little dots are plants that they're building. They're building a biochar fertilizer plant every 3 weeks in China. So they're serious about biochar. In that case, they're actually taking the crop residues, the wheat straw and corn stover, and providing the farmer an incentive for taking his waste product to the fertilizer plant instead of burning it in the fields. They're trying to reduce the pollution from open field burning. And they make a granulated product that you can see there in the lower right. So what are they worth? Depends on how good a salesman you are. Biochar prices vary. The values depend on their properties. Processing and use can go from 12 cents a pound to $1.50 a pound. Actually, there's a product being sold for controlling residual mercury from a legacy DuPont plant in Virginia that is being sold for about $3 a pound. So depending on the quality, biochars have different qualities with regard to, depending on how you want to use it. Some uses require higher carbon content. Others don't require higher carbon content, but if you have other nutrients in your waste stream, like sulfur, for example, the biochar can have value of typically a more common value at the plant where you're producing it is about 25 cents a pound. Market value is typically 50 cents a pound. And again, used in these kinds of markets that I've described. How much processing is necessary? What should you do to biochar? How is it used? Unfortunately, about 10 years ago, biochar got pumped up as being a be-all and end-all. Everybody thought biochar was going to be the answer to everybody's solutions, and so there were over expectations for its use, and everybody wanted to use biochar as kind of a silver bullet. Just add biochar and that was going to solve the problem. What's happened over the last 10 years is we've realized that less is actually more. A little bit of biochar can go a long way. The typical additions of biochar might be 5% to a combined product. And then people say, well, it's not the biochar. Well, biochar acts as kind of like a catalyst. It's a helper, a hamburger helper or whatever. It helps things along the way. But on its own, 100% biochar, if you put a heavy dose of biochar on your lawn, you're going to kill the grass because it's going to rob all of the nitrogen from the grass. But if you lay in small layers of the material, then it can be beneficial. There are efforts, too, to take the biochar and activate it to make it a poor man's activated carbon. And in a lot of ways, can be a direct substitute for activated carbon in things like odor control. Here's an example of biochar use from our friend David Yarrow. It's just graphically, visually here on the right-hand side. If you look at biochar, soil and compost for biochar, compost, and soil. If you have a 1-to-1 mix of compost and soil, you can see the growth, lettuce growth on the right. Compost alone, the next one over, and 20% biochar, the third, and 10% biochar on the fourth. So you can see there's greater growth actually from just 10% biochar. So this is just to illustrate that it doesn't take much to have a beneficial effect. What we're finding is that biochars are ingredients of high-value retail garden products. You can actually find biochars or products that contain biochar in a lot of garden centers today, and that helps us because it makes people more aware of the fact that biochar exists. Here are 3 products, Rexia's products out in Oregon, Kellogg Garden Products, which is distributed nationally in 1,000 outlets, Carbon Gold from the UK, each kind of pitching different markets. Rexia's, we got to try biochar about 5 or 6 years ago. They found they loved it. They created a whole product line based on biochar. Kellogg Garden Products, I think they add about 10% biochar to one of their standard garden mixes. And Carbon Gold specializes in, they're also now here in North America, and they're specializing in products that for commercial horticulture. And there are a number of other products. You can see a whole list there of products that contain biochar. So it's growing slowly. Here's an example of using biochar to improve soil organic carbon. Many of our agricultural soils have low carbon, less than 1%. This particular farmer, J.R. Bollinger in Missouri, had about 0.7% organic carbon in his soils. He came up with the idea of using biochar as a component with other organic components in what's called strip tillage. These are 6-inch wide strips on 30-inch centers. You put this menu of ingredients into the furrows, let it biologically cook for a couple of weeks, and then took his GPS-guided tractor and seeded right on top of it, wound up doubling his yield and wound up selling out his future crops for the next 5 years to a Japanese buyer. The idea was that he would take that 6 inches, move it over 6 inches, and in 5 years he would cover the entire acreage and improve all of his soil. What he's done, in fact, is he took the first 6 inches, moved over 6 inches, and then he moved back to straddle the first 2, and he's brought soil organic carbon up to 5% in his planting strips. So he's improved the productivity of the soil, and he's brought the worms back. He didn't have worms in his soil before, and now he has a very healthy soil. Here's his equipment, conventional strip tillage equipment. Dry ingredients go in the big tank on the right, liquid ingredients go on the left. There are 16 individual units that fluff up the soil and combine the ingredients. JR has been very innovative, and again, he's been very productive, and he was able to survive a drought episode which knocked out a lot of his neighbors by using partly biochar in the mix and increasing the organic matter. 1% organic matter is worth 25,000 gallons of water. So increasing organic matter through a combination of compost and biochar is beneficial. Here's an example of compost rows using biochar. In California, they believe that adding biochar to compost is going to be a useful way of controlling greenhouse gas emissions, which will be regulated from composting before long. Here's some more. There's a tomato grower in the San Joaquin Valley is using biochar in his tomato harvest. Been very happy with the results. Results have been monitored by the University of California, Davis. Here's liquid biochar. Biochar is squirted out in liquid form. Biochar slurry, this is on the left-hand side in no-till drilling. If you're familiar with no-till agriculture, continuous injection of urea and ammonia can create acid situated conditions so that when you're seeding, that seed drops into an area that's got a pH as low as 2.5 or 3. Add some liquid biochar and it brings the pH up to 5 or 6. Makes a healthier environment for the seed to grow. On the right-hand side, here's again a biotic soil amendment by Lesko for spraying on golf courses. An example of the environmental remediation type products, capture nutrients, metals, organics in bioswales on the left-hand side, and the right-hand side using it as part of leachate control filtration. That system's been in for about 6 years now, and right down to the bottom, very simple hydroseeding, erosion control, just add biochar, about 10% of the mix. Use in building products, here it is in a wall board type product in Switzerland. Here's biochar being used in urban environment in Sweden. City of Stockholm was having problems. They were losing 15 to 20% of their trees. They started grinding biochar, grinding the aggregate to a small size, combining it with biochar, and they wound up making a good growing media. Now they've got healthy trees. There are now cities throughout Scandinavia that are copying them. Here's an example of the equipment they're using to make the biochar. This is called a pyrolyzer. Heats the urban wood and creates charcoal and heat, and the heat is being used in this case for heating apartments, and the char then is used in the urban landscaping. Here's another way of making biochar. You basically heat it in a heated auger. In this case, it's partially electrically heated, but the electrically heated portion is simply to keep the tars and oils from sticking. This is a French unit. There are about 100 of them in operation. There are a few of them here in the United States. It would be an ideal situation if you've screened out fines to the point where you've got that 3/4 inch material that Tim was talking about. That can flow fairly easily. You can drop it into the carbonizer, which is, there's a dryer on the left-hand side, the carbonizer in the middle. You can see the charcoal coming out in the cooler in the bottom. And then you can take the oils that come off of the process and condense them into oil if you've got a market for the oil, or you can actually take the oils and non-condensable gases and use them as fuel to burn them directly and generate heat. Here's a mobile unit made by a company called ROI. I don't know whether they're exhibiting here or not. This is actually a big box with controlled air for burning. There are about a dozen of these now that have been sold. They're relatively new. The oldest has actually been operating for exactly a year at a recycling operation, C&D operation in Texas. What it is basically is you build a deep bed fire. You wind up at the base of the fire with a pyrolysis situation, a situation where you have combustion gases without any air, and so you're heating the wood in that zone. It's creating about 80% of the wood will convert to a gas before it burns, and so the rest of it is charcoal. So what you're doing here is that you're basically building up a bed, in promoting the charcoal production, and then you're pulling. There's a grate at the bottom of it, a screen, and so you pull the charcoal out. So here you can do the volume reduction and still wind up with a charcoal byproduct. There are several producers actually doing that now. Here's a demonstration we did in Central Oregon just a couple of months ago with the unit operating. You can see the loader on the left-hand side, dropping the wood into the burner, nice clean emissions, and the charcoal goes out the end, and in this case it's being dropped into a tote for demonstration. One of these operations in Florida is producing about 15 cubic yards of biochar that he's selling for $120 a cubic yard. every day. So biochars can be delivered in bulk. Here are some 2 cubic yard bags. Here's a bulk truckload. You can see some screened and washed biochar on the left-hand side, rice grain-like in production. We do have standard specifications and certifications. They're voluntary at this time. The International Biochar Initiative came up with a series of standards for the purpose of monetizing the biochar. If you put it in the ground and it's going to last for thousands of years, then what's it worth? Can I get a carbon credit for it? That process of getting that protocol accepted by everyone is still in process with the American Carbon Registry and the California Air Resources Board. We're still working on, nobody quite agrees on how long is that carbon going to be there and what's it worth, but hopefully we'll see that at some point. But we also have in the International Biochar Initiative standards, we have the minimum kinds of levels of pollutants that you can have in the biochar, the kind of thing that Tim demonstrated. There are other definitions and standards as a soil amendment. If you're going to put a label on something, on biochar or a soil amendment, it has to be approved by the Association of American Plant Food Control Officials. They're the Gestapo that works in every state. The state agricultural agencies control labeling, and they typically follow the AFCO standard. AFCO has a definition for biochar. For organic products, there's the Organic Materials Review Institute. California Association of Air Pollution Control Officers now has a standard. The USDA Natural Resource Conservation Service now has a protocol that they've approved for using biochar in agriculture. So in summary, the production of biochars and enhanced biochar products is growing for urban wood waste, forest, agriculture, industrial, and environmental markets. We see the markets are expanding with better quality products and in non-soil uses. What we're seeing actually is the maturing of an industry. If you turn the clock back on construction and demolition or in composting 20, 25 years, that's kind of where we are. We're just starting out. Production systems are increasing in quality and capacity and mobile flexibility, and biochars create new market opportunities for increased value from clean recycled wood. So we think there are opportunities, especially on the wood, paper, mixed fraction. We're just kind of getting started and seeing how biochar might fit in your industries. But we think there might be some compatibility in terms of reducing volume and producing value-added products. And now we've got some commercial examples out there that we can point to around the country of people actually doing that. So thank you very much. I hope this has helped your understanding of biochar.
Okay, thank you very much for attending today.
Thank you.